In this video, I'm going to discuss about functions or types of functions that do not have derivatives. The classic example is the absolute value function. So let's consider scenario 1. Your f of x is equal to absolute value of x. If you graph it, by the way, this is how it looks like. It's the V-shaped function. It has derivative to the right of 0, derivative to the left of 0. However, at x equal to 0, it does not have derivative. So the types of function that have sharp corners, okay, that will not have derivatives. For example, if you have a function like this, it will not have derivative at this point, at this point, at this point, at this point, at this point. So anything that has sharp corners. Second category is this, where there is an obvious discontinuity of the function. So for instance, you could think of step functions. There are functions that will be something like this. Then it starts here, goes there, then maybe starts here and goes there. At this point, there is no derivative because left limit and the right limit is not going to be the same. It's the same argument most of the time, so you'll use if the derivative doesn't exist, the reason it doesn't exist is that the left limit and the right limit do not match. They are not the same. So this is another type of functions you could think of where the derivative does not exist. And yet a third type will be something like this, where you have a function that's going like this, maybe. And somewhere around here, the slope will be infinity. Let's say x is equal to a. Or you could have some other shapes, where something like this. Here the slope is going to be, let's say x is equal to some point b. The slope is going to be infinity. If that is the case, then obviously the derivative does not exist. One classic example of non-existence of derivative is this. Let's say you have a function that is continuous everywhere. Okay, everywhere means on some closed interval from a to b. And just a reminder, closed interval looks like something like this, from -1 to 1, where the boundary points are included. So you have a function, let's say we call it f of x, is continuous everywhere in this interval. Okay. Now, this function may be differentiable everywhere inside the open interval a to b. Is possible, okay? Even polynomial functions, which are different, continuous everywhere and differential everywhere, right? So what's going to happen at the boundary point is this. As far as our function is concerned, it's defined only for the closed interval, okay? So the right limit, let's say for a, the right limit exists, okay? So no problem there. However, for a, the left limit does not exist. Why? Because the function is not even defined in that beyond a to the left. Similarly, for b, what happens? The left limit does exist because to the left of b, the function is okay. However, the right limit to the right of b, the function is not even defined. So the question of limit doesn't make any sense. So it does not exist, right? Does not exist. These are the typical scenarios where the derivative of a function does not exist, okay? So keep in mind these sharp corners, these steps or discontinuities, and then this kind of graphs where slope at a certain point is infinity or undefined. I hope that this discussion was helpful. Thank you very much.